In this video, we'll be taking a look at section 5.4, which covers the other trigonometric functions. So we have looked at sine and cosine, but there's more than just those. We're going to focus on the tangent, secant, cosecant, and cotangent functions. And we're going to start with the same picture that we did for sine and cosine. So for the point x, y on a circle of radius r at an angle of theta, we can define 4 additional important functions as the ratios of the sides of the corresponding triangle. So if we take theta to be this angle here, then the tangent function, tangent of theta, is going to be equal to y over x. The secant function says the secant of theta is equal to r over x. The cosecant function is the cosecant of theta is equal to r over y. And the cotangent function, cotangent of theta, is equal to x over y. Now you may notice the similarities between secant and cosine, between cosecant and sine, and between cotangent and tangent. And those are outlined here in these trigonometric identities. So the functions introduced on the previous slide can all be related back to sines and cosines. So all of our trigonometric functions that we have so far can be written as sines and cosines. So tangent of theta is equal to the sine of theta over the cosine of theta. The secant of theta is 1 over the cosine of theta, so that means it's the reciprocal of cosine. Cosecant of theta is equal to 1 over sine of theta, so that means cosecant is the reciprocal of sine. And then the cotangent of theta is 1 over the tangent of theta, which means it's the reciprocal of tangent. And if we flip the fraction that tangent is equal to, sine over cosine, we get that cotangent can also be written as cosine over sine. So these trigonometric identities are going to help us be able to solve some things moving forward. So let's see what we can do with this. If theta is equal to negative pi over 4, we want to find the exact value of the following. And we want to find the 6 trigonometric values. I'm going to start with a picture. So we don't see degrees on our negative pi over 4, so we know we're working in radians. Notice that it's negative, so instead of going counterclockwise around the circle, I'm going to go clockwise, and I'm going to go pi over 4 radians. So that is an angle of negative pi over 4. Now that angle, I don't have those specifically written on my unit circle, so let's think about this in terms of a reference angle. My reference angle is the positive angle between where I'm at and the horizontal axis. Well, to get from the horizontal axis here is negative pi over 4, so to get from here to the horizontal axis will be positive pi over 4. So if I can find these values for pi over 4, then I'll be able to find them for negative pi over 4, because I just have to remember that I'm in quadrant 4. In quadrant 4, cosine is positive and sine is negative. Tangent is sine over cosine, and a negative divided by a positive is negative. Cosecant is the reciprocal of sine, so 1 over a negative is negative. The secant is the reciprocal of cosine, so 1 over a positive is a positive. And cotangent is the reciprocal of tangent, and 1 over a negative is a negative. So at least I have the signs of all of these. So now we need to find the actual values. I'm going to think of pi over 4. And I have my handy dandy little unit circle here. I'm looking at pi over 4. And it says that the point on the unit circle corresponding to pi over 4 is square root of 2 over 2, comma, square root of 2 over 2. So the sine value comes from the y value on the unit circle. So the y value on the unit circle where I'm at is square root of 2 over 2. Work with me here, autofocus. But we said because we're in quadrant 4, our y value is negative, so this is going to be negative. So the sine of negative pi over 4 is negative square root of 2 over 2. Cosine comes from the x value here. It's going to be positive, and it's square root of 2 over 2. Now we have the tangent of theta. Remember that tangent is equal to sine over cosine. So if I take my sine value, negative square root of 2 over 2, and divide it by my cosine value, square root of 2 over 2, then I can do my keep, change, flip. I keep the first one, change to multiplication, flip the second one. The square root of 2's cancel, the actual 2's cancel, I'm left with negative 1 times 1 is negative 1. So the tangent is negative 1. Next up we have the cosecant. Cosecant is the reciprocal of sine. So I'm going to have negative 2 over the square root of 2. But I'm going to rationalize that denominator so I don't leave a square root in the denominator. And I do that by multiplying by the square root of 2 on top and bottom. That gives me negative 2 times the square root of 2 over the square root of 2 times the square root of 2 is the square root of 4, which is 2. And those 2's cancel out, leaving me with negative square root of 2. Next up, we want the secant of theta, which is 1 over the cosine, or the reciprocal of cosine. So if I do the reciprocal of cosine, I'm looking at 2 over the square root of 2. I'm going to rationalize that again by multiplying by the square root of 2 in my numerator and denominator, which gives me 2 square root of 2 over 2. The 2's cancel, leaving me with just a positive square root of 2. And it's positive, and that lines up with what I wanted. Finally, we have the cotangent of theta, which is the reciprocal of tangent. So if I write that as 1 over negative 1, that's just negative 1. So the cotangent is also negative 1. We're going to keep working with these other trig functions. This time they tell us if cosecant of theta is equal to 9 over 4, and theta is in quadrant 2, we want to find the sine, the cosine, the tangent, the secant, and the cotangent. Well, the cool thing about this is, if we know the cosecant, then we know the sine, because sine is the reciprocal of cosecant. So I can just flip this. The sine is 4/9. All right, so that gives us the sine. We still need cosine, tangent, secant, and cotangent. Well, remember, sine is the sine of theta is y over r. So they gave me my y and my r value. We know that x squared plus y squared equals r squared because we're working with right triangles. So if I know my y value is 4, my r value is 9, I should be able to solve for x. So x squared plus 4 squared equals 9 squared. So that means x squared plus 16 equals 81. If I subtract over the 16, I get that x squared is equal to 65. I was trying to take the square root in my head already. And if we square root that, we get x is equal to plus or minus the square root of 65. But they told us that we are in quadrant 2. In quadrant 2, that's the upper left-hand corner. And up there, our y values are positive, but our x values are negative. So I don't want the positive here. I want the negative square root of 65. So now I just have to fill in the blanks for cosine, tangent, secant, and cotangent. Cosine is x over r. So that will be negative square root of 65 over our r value of 9. Tangent is y over x, which will be my y value is 4 over my x value of negative square root of 65. I'm going to rationalize that by multiplying by the square root of 65 in my numerator and denominator, which leaves me with negative 4 square root of 65 over 65, and that doesn't reduce. Secant is the reciprocal of cosine, so that'll be negative 9 over the square root of 65. And if I rationalize that, I'm going to get negative 9 square root of 65 over 65. And finally, cotangent is the reciprocal of tangent. So I could take the reciprocal of this, or I can just take it as the reciprocal of tangent. And if I flip that, I get negative square root of 65 over 4. So using these reciprocal properties can be really useful. Remembering your x, y's, and r's, how those all interact, can be useful. So make sure you're practicing all of these different ways we have of describing each of our trigonometric functions. Now what we're going to do next is something that people typically either really, really like or really, really don't like. And it's going to be establishing identities. Now with establishing identities, we're going to prove that some sort of relationship is true. So identities are relationships between expressions that are true for all values of the input on which they are defined. When you are attempting to establish identities, you cannot treat the identity as an equation, meaning you can't add the same thing to both sides, you can't multiply the same thing to both sides. You have to work with only one side at a time. So some things that might help. Start by working with the side that looks more complicated. It's usually easier to make something more simple than it is to make it more complicated. You can try switching all the terms to sine and cosine. Sometimes that really helps. Factoring can be useful. Multiplying by a useful 1 can help with fractions. So if you have a gross denominator, sometimes that helps out. Don't forget you have the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. And then once you've established an identity, you can use it in the future. So if you prove something that's super complicated, but it helps you in the future, just say, I proved it once, don't have to prove it again. No, I won't accept that on a test. You got to actually show me, but hey, at least it'll save some time. So we're going to start by proving that 1 plus the cotangent of alpha over the cosecant of alpha is equal to the sine of alpha plus the cosine of alpha. Now I'm going to start with a side that looks more complicated. Sorry, sine and cosine, but this cotangent and cosecant stuff looks a bit more complicated. I'm going to try breaking up my fraction and see if that helps. I'm not going to touch this right-hand side. I'm going to leave it alone. So if I break up this fraction, that's 1 over, let's try a different marker. That's 1 over the cosecant of alpha plus the cotangent of alpha over the cosecant of alpha. I'm going to try switching everything to sines and cosines because sometimes that helps. So that's 1 over. The cosecant of alpha is 1 over sine. So it's 1 over the sine of alpha plus cotangent is the reciprocal of tangent, and that meant that it was cosine over sine. So we get the cosine of alpha over the sine of alpha, and we said that cosecant is 1 over the sine of alpha. I'm going to do some keep, change, flip here because I'm dividing fractions. So in my numerator I have 1, change to multiplication, flip, so we get sine of alpha over 1, plus, I'm going to keep, change, flip this guy, keep cosine of alpha over sine of alpha, change to multiplication and flip sine of alpha over 1. Over here, I have 1 times the sine of alpha. That's just the sine of alpha. Whoops, plus. And then I have a sine in numerator and denominator. Those cancel. I'm left with cosine over 1, which is cosine of alpha. And you'll notice that equals the sine of alpha plus the cosine of alpha that they wanted us to have it be equal to. So what we're doing with these is playing around with them until we can show that one side is equal to the other. Let's try another one. We're going to prove that 1 plus tangent squared equals secant squared. Those both look relatively harmless, but since there's a plus sign on this side, I'm going to work with that side. So I'll try switching from tangent into sine and cosine. So it'll be 1 plus tangent is sine of theta over cosine theta, and that is squared. Well, that means I have 1 plus sine squared theta over cosine squared theta, because I can distribute the square to both the numerator and denominator. Now remember, one of my useful tricks was to multiply by what I called a useful one. And what that is multiplying by the same thing in numerator and denominator. So what I'm going to do is I'm going to multiply this 1 by the cosine squared of theta over the cosine squared of theta. That way, these two terms are going to have the same denominator. So cosine squared of theta over cosine squared of theta plus sine squared of theta over cosine squared of theta. Our goal is to get to secant squared. Well, now these have the same denominator, so I can combine them. And we get cosine squared of theta plus sine squared of theta over cosine squared of theta. Don't forget, we have the Pythagorean identity that says sine squared plus cosine squared equals 1. This is written in a different order, but we still have cosine squared plus sine squared. They're still added together. So that's equal to 1 over cosine squared of theta. That's the reciprocal of cosine, but squared. The reciprocal of cosine is secant. So this is secant squared of theta, which is what we wanted it to be. We're going to try the second one, which is very similar. We want to prove that cotangent squared of theta plus 1 is equal to cosecant squared of theta. So when I say these are similar, it's because these are alternate forms of the Pythagorean identity. It's just a different way we can write them. We tend to use the sine and cosine one the most because it's the simplest and it's the easiest to remember. Well, let's see if we can prove this other one, that cotangent squared plus 1 is equal to cosecant squared. I'm going to try that whole switching it to sines and cosines again. Cotangent is cosine over sine. So this will be cosine squared of theta over sine squared of theta plus 1. I'm going to multiply that 1 by sine squared over sine squared. That way I have cosine squared of theta over sine squared of theta plus sine squared of theta over sine squared of theta. And now they have the same denominator, so I'll add them together. Cosine squared of theta plus sine squared of theta all over sine squared of theta. But cosine squared plus sine squared is equal to 1. So this is 1 over sine squared of theta, and that is the reciprocal of sine squared. The reciprocal of sine is cosecant, so this is cosecant squared of theta, which is what we wanted it to be. Now that's the last slide I have, but these ones tend to be kind of tricky, and when people get to the homework, they tend to struggle. So I'm going to do one that's similar to these, but worded a little bit different, and we have a slightly different goal in mind. And this should mimic a couple of your homework problems. We are going to simplify. Let's back up a little bit. We're going to simplify the tangent of t over the secant of t minus the cosine of t to a single trig function. So apparently, if we manipulate this enough, then we are going to get to a single trig function, something like sine or cosine. That's going to simplify that far. Now we don't even have two sides to work with, so I'm going to have to do something kind of sort of fancy here apparently. I'm going to try what I usually start with, and that's switching everything to sines and cosines. It is going to get messy, but things are going to cancel out pretty quick. So tangent is sine over cosine. So in my numerator, I have the sine of t over the cosine of t. In my denominator, I have the secant of t, which is 1 over cosine of t, minus just the cosine of t. The problem is I can't combine these two terms. It'd be really nice if my denominator went from having subtraction in it to being all one term, and then I could keep, change, flip. So what I'm going to do is I'm going to multiply my cosine of t by cosine of t over cosine of t. Because that's multiplying it by 1. It's a really weird 1, but it is 1. So everything else is going to stay the same for now. We have the sine of t over the cosine of t over 1 over the cosine of t minus, I took cosine times cosine over cosine, so that'll be cosine squared of t over the cosine of t. So now in my giant denominator, both of my denominators match. So I can combine those together. I'm going to leave the top alone, sine of t over cosine of t. In my denominator, I have 1 minus cosine squared of t all over the cosine of t. All right, let's try this keep, change, flip thing. So we keep the numerator as sine of t over the cosine of t, change to multiply, and flip. So we have cosine of t over 1 minus the cosine squared of t. These cosines cancel, and I'm left with sine of t over 1 minus cosine squared of t. Now remember, we're trying to get this down to a single trig function, but this thing in the denominator looks sort of familiar. I wonder if we know anything about it. Remember, we have this Pythagorean identity that says sine squared of theta plus cosine squared of theta is equal to 1. We know that's true. So if that's true, I can subtract cosine squared from both sides, and I get that sine squared of theta is equal to 1 minus cosine squared of theta, which is that. This denominator is sine squared. So this is the sine of t over sine squared of t. One factor of sine cancels out, so I'm left with 1 over the sine of t, which is the reciprocal of sine, which is cosecant of t. So sometimes it takes a little bit of fiddling around, playing with what you've got. Most of the time, there are dozens of ways to get to your answer. Find a way that works, see what you can do.